Welcome to GK Tech Course. Let's dive in. If you are preparing for a Java interview, there is one question you will be asked: how does a hash map work internally? Today we are going to deconstruct this step by step. We will see how Java handles your data. Before we dive into the main details, let's see what HashMap can do. A HashMap is a part of the Java collections framework. It stores data in key value pairs, and internally it uses an array of buckets where each bucket holds data either in a linked list or a specialized tree structure. Three quick facts to remember: it allows one null key and multiple null values. It is not thread safe because no synchronization. Because it's unsynchronized, it is very fast in a single threaded apps. Now we'll move to main discussion, that how HashMap works internally. When we write map.put, a lot happens behind the scenes. To understand the journey of that, I have broken the mechanism down into a logical 6-step flow. The first step is the foundation. It's buckets. We already talked HashMap internally uses an array of buckets. When you initialize a HashMap, it starts with a default capacity of 16 of these buckets. Each bucket is essentially a slot where data can store. Let me show you the block diagram to understand what is an array of buckets. So this is how it looks internally as an array of buckets having default size is 16, and the data will be placed inside the bucket. So each index represents the bucket. We'll see how the data will place from step 2. So this step 2 is hashing. When we write map.put, Java does not just pick a bucket random. It takes your key, runs the hash code, and uses a bitwise formula to calculate the exact index or address of that bucket, and it will store data into that bucket. So in the step 3, it is the data will store in a node object. Okay, this node stores the hash and key value and a pointer to the next node. Let me show you the block diagram to understand this. So whenever we call put method, using that key, it will calculate the hash code and find the right index of that bucket, and it will store data into that bucket in a node object. See here, there is a employee key, and it based on a hash code, it identify the index and keeping that data into that bucket, right? This is how it will store data into the node. This node will have hash code, key, value, and next node refer to the next node. We'll see what is pointer to next node from step 4. So this step 4 is hash collisions. What if two different keys result in the same bucket index? This is a hash collision. It means two different keys also, the algorithm generate the same hash code and finding the same bucket. Okay, that is called hash collision. So that time, instead of overwriting the first key data, the hash map creates a linked list within that bucket. If the same key and same value, then it will override, but different value, then it creates the new node, simply attaches to the next pointer of the existing one. So here in this block diagram, so how different keys placing like a linked list, right? So here 3 keys having the same hash code and finding the same bucket, and the data will store in a node object and which is pointed to the next node. Like a linked list, it will store. So the data goes increase, let's say. Okay, the linked list also will increase. So this will have a one capacity, that is 8. It reaches the size 8. Okay, then Java 8, from Java 8 onwards, it introduced Treeification, okay, to improve the performance of search. So when we use, if you see here, Treeification. So if a bucket gets too crowded, specifically more than 8 elements, Java performs a upgrade. So it converts that messy linked list into a red black tree to keep search time fast. And the final step, rehashing. So finally, once the map is reached to its load factor, it means the data increased, the map size increased. So based on load factor, so what it will do, it realizes it's getting more data. It doubles its capacity from 16 to 32 buckets and moves every single element to a new calculated position. This keeps the map efficient and ready for more data. This is called rehashing. Now we will see the complete flow. So when put operation, check key is null. If yes, it will go to the index 0 bucket. This is very important. If key is null, means hash code, it will not generate any hash code, and it will, by default, it will give you the index 0 bucket, and the null record always store into the index 0 bucket. Okay, let's say we have received key is not null, then it will go to the compute hash. It will generate one hash and identify the index. Okay, find the bucket index, and if bucket is empty, directly it will insert the data into the node object. Okay, if it is not empty, it means already this other data is there. Okay, then it will do same hash collision. Okay, if yes, it will go to the linked list. It will arrange the linked list. If it is no same hash collision, directly insert normally data. Okay, if that linked list size is greater than threshold, so threshold is 8, it reaches the 8, then it will convert to a red black tree. If not, normally it will add the linked list. Now we'll see how get will work. So to identify the, while you are reading the get key, okay, if key is null, it will direct to the, go to the bucket 0 and check the first node, and if key matches, it returns the value. Okay, if key is not null, then it will compute hash using that key and find the bucket index, and it will go to the first node. It will check the first node. If key matches, you need to remember, so once hash code is matched, it will reach to the bucket, but you need to match the key also, right? In HashMap, it's very important to check the equal condition. You should override the hash code and equals condition, right? So if key matches, then it will return the value. If not, it will go to the next node. Okay, so we already know it stores the data in a linked list. Okay, so it will check the next node. If next node exists, and it will move to the next node and it will key match, it will give the return value. If there is no key matched, and it will give the null value. This is how get will work. So the important interview points you need to remember: default capacity of HashMap bucket size is 16, load factor is 75%, one null key allowed, and it is not synchronized. Fail fast iterator. It means when you are, if any iteration is going and you're modifying the same map, okay, you will get a concurrent modification error. So that is called fail fast iterator. Order not guaranteed, and Java 8 tree optimization introduced, and equals plus hash code must override together. Thanks for watching GK TechVerse. Subscribe, stay consistent, and keep upgrading your skills. See you in the next video.